In this video, we want to learn how to draw the Lewis structure for complex compounds. Okay, for complex compound. Right? The Lewis structure for complex compound. If you don't know how to draw the Lewis structure for elements and molecules, you can check out our first video on the introduction to Lewis structure. Now, we have the periodic table over there so as to show us the number of valency electrons that is in each of those elements. And let's start off with carbon 4 oxide. Carbon 4 oxide, CO2. Now, what's the Lewis structure for carbon 4 oxide? First of all, you count the number of valency electrons that is in the compound. Now we have carbon. How many carbon do we have? I have 1. So 1 times by, what's the valency electron for carbon? That is 4. 1 times 4, that is 4. How many oxygen do I have? I have 2. Now 2 of those. What's the valency electron for oxygen? That is 6. What I'm going to do is 2 times 6. What I have is 12. What's the total number of valency electrons that I have? 14 plus 12 will give me 16 valency electrons. Now, having said that, up next is to look for usually the single atom of element there, which is carbon. So I'm going to make carbon my central atom of element, and then I'm going to take a bond and form oxygen on both sides of the carbon atom. Are you following now? Or the carbon element. Now, when I've done that, this is 2, this is 2. Please. 2 plus 2 is 4. We're going to subtract 4 from the 16 electron because this one single bar means 2 electrons. This one single bar means 2 electrons. So 2 plus 2 is 4. We're subtracting it from 16. We're going to have 12 remaining electrons. Now, these 12 remaining electrons, they are going to form a lone pair electron on the oxygen atom. Lone pair electron is like this: 1, 2, 3, 4, 5. Okay, this is 4, 5, 6. This is 4, 5, 6. All right, so we have 3 lone paired electron, 3 lone paired electron plus 2 from here, 6, 6, 12, 2. What's that now? And 2, that's 16, completing this. All right, now, but notice that the carbon is not smiling because we have 6 here, 6 plus 2, 8. Oxygen is balanced. 6 here, 6 plus 2, 8. Oxygen is also balanced on both sides, but the carbon is not balanced. So what we're going to do is that one of the oxygen, each of the oxygen will transfer a lone pair into this place. It will transfer a lone pair into this place. So what we have is double bond, oxygen. So I'll be having the other lone pairs, 1, 2, 3, 4, 5, 6, 7, 8. Now, the lone pair that is transferred from here is 2. The lone pair that is transferred from here is 2, forming a single bond. Are you following now? So what we're going to be having is plus this bond that is already there, double bond. So I have 4 here, 4 plus 8. 4 plus 4, that's 8. 4 here, 4 plus 4, 8. This one is 4 here, 8, 4, 4. 4 from this both side. 4 on both sides is 8. So this is the Lewis structure for carbon 4 oxide. Let's do for the one of water, H2O. Now we're going to calculate the total number of electron in it. Now hydrogen is 2 of those and is 1. The valence number of hydrogen is 1. All right, so we're going to be having 2 here. Then for oxygen is 1. And the valency there of oxygen is in group 6. So the valency there is 6. Now this is 2 plus 6 or 6 plus 2. I think that should give me 8. All right, 8 valency electrons. Now, as you have done that, what you need to do is that pick the single element there. Hydrogen is 2, oxygen is 1. So oxygen is single. So I'm going to put oxygen as my central atom. And then meanwhile, I'm going to add the hydrogen on both sides. Add hydrogen on both sides. Of course, if you are to add, you are to add it in this manner. First of all, add it in this manner. And then this is 2, this is 2. That is 4. 2, 2, 4. The 4 minus the 8 total number of electrons, remaining 4. So I'm going to be adding 2 lone pair, 2 lone pair, 2 lone pair, making these to be 2, 4, plus 2, 6, plus 2, 8. Hydrogen is 2, and you need only 1 electron to become duet. So hydrogen is 2, 2 electrons become duet. So this is balanced, this is balanced. Now, if this electron cloud, we push these hydrogen atoms towards making the bond to form a V shape or a bent shape. So finally what I'll be having is oxygen atom, hydrogen, hydrogen, and then I will have the lone pair, 2 lone pair, 2 lone pair. All right. Now, this is also known as a polar substance, as a partially positive charge and a partially negative charge. That's what you do. Now, let's draw for the one of SO3. Okay? What's the valency? What's the Lewis structure for SO3? And Lewis structure for SO3 is the same method. How many sulfur do I have? 1. So it's 1 times, what's the valency number for sulfur? That is 6. 1 times 6, that is 6. Oxygen. Oxygen is how many? 3. How many oxygen do I have? How many, what's the valence of oxygen there? It is, oxygen and sulfur is the same thing, 6. 3 times 6. 3 times 2 is 12 plus 6, that's 18. So I have 18 valency electron. And if I add 6 to 18, that will give me 24. So I have 24 valency electron. And if I've done that, what's the central atom that is there? The central atom that is there, can you see this side of the board? The central atom that is there is sulfur. Now, we're going to form 3 bonds. So 1, 2, and then 3. All right, so we will form 3 bonds. 1 here, 1 here, and 1 here. Remember that this is 2 electron, 2 electron, 2 electron. All this is 6 electron. Now 6 minus 6 from 24, it will go back to 18. All right. So if you go back to 18, I will distribute the 18 electron round the oxygen atom as a lone pair. So let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not up to 18. 11, 12, 13, 14, 15, 16, then 17, 18. Now, if I've done that, let me take them close to each other so you don't get confused. All right. Put them close to each other. Now, if this is this structure, this is 6. 6 plus 1 is 8, balance. 6 plus 1 is 8, balance. 6 plus 1 is 8, balance. But the oxygen is suffering. Oxygen needs 2 more electrons, so that 6 here, 2, 2, 2, 6 plus 2 becomes 8. One of these oxygen will borrow the cloud, the lone pair electron to the sulfur. So now what will happen is that, let's take this guy, borrows this guy, okay, the electron will enter here, so that the structure we will now have will become like this. Let's use this side of the board. So we have sulfur having these bonds, all right? Notice it become 2 bonds now. So I have oxygen atoms in it, all right? Now remember, the number of lone pair we have, up there, don't confuse this, all right? Don't confuse it, all right? So it will become this. This is oxygen. So I have, how many is there now? 1, 2, 3, 4, 5, 6. How many is at the other side? 1, 2, 3, 4, 5, 6. How many is remaining when I've taken away 2? Just 4. 1, 2, 3, 4. So this is 4. 4 plus 4, 8, balance. This is 6. 6 plus 2, 8, balance. 6 plus 2, 8, balance. This is 2, 4, 6, 8. So this is the Lewis structure for this compound, which is triazosulfide. All right. Now, meanwhile, find the Lewis structure for H2SO4. Okay, can we find one more for you? Find the Lewis structure of HCl. Find the Lewis structure of ammonia. All right. Now, when you do that, you drop your answer in the comment section. I will be glad to hear from you. This is all we've got for you. Thanks for watching. Have a great day.